I'm audible now.
Yes, sir. Yes.
So, as far I know, today's discussion topic is on the decision tree, card, and ID3 algorithm. Right? Am
Yes.
I right? Yeah. Okay.
Yes, sir.
So you already got that. Why do we need to go for construction of a decision tree? And you have seen that this is a part of supervised learning, where we are already aware with those class levels, right? And our main aim is to find out that new data points class level. Okay, so we go for constructing a tree starting from a root node. We try to split it, and split it means we are generating the successors or children. Okay, we go on doing that when until and unless we reach the leaf node. As I have said that we try to split that node. That means there should be some condition based on which we will go for that splitting. Okay, so that is the criteria by which we may have different types of decision tree algorithms. And as per our discussion point of view, today's main concentration will be on that how this ID3, okay, card algorithm differ from each other. So they actually based on these different attribute measuring techniques, their goodness measuring techniques, and based on which we will split the nodes. So now I would like Ankit to start the session, and so best of luck to all of you. Please start.
Okay, discussion will be start from the MSc ID student. So MSc ID roll number 1. Roll number 1 is present. No, I think. Roll number 2. Okay, Gopal Kuor is present. Gopal, you can start your presentation.
Okay. Hello. Is my skin is visible? Hello.
No, till now. Oh yeah. He's coming. Wait. Yeah. Yeah. You can start.
Our discussion topic is card and ID3. Now, what is card? Classification and regression tree, shortly card methodology.
Gopal,
yes, sir.
Press F5.
F5.
Or that this from beginning. Okay, here you can see that from beginning. Just click that. And I would like to inform all of you that this is not a kind of forceful means that forcefully I want all of you to participate or discuss these things. Okay, this will be a benefit for you only. Okay, you know, if you present, you will learn something, and if you actually learn something, obviously that is your own benefit, right? So
yes, sir.
ভাবি নল'বা তোমালোকে যে এইটো তোমালোকৰ ওপৰত জবৰদস্তি কৰা আছে বা তোমালোকক কুৱেশ্যন সোধা যাব এনেকে no I am not that kind of difficult that I am going to ask this type of things to you. Okay, so I want this discussion as from your own part of willing. Okay,
yes,
so
sir.
Gopal, press F5.
Sir, F5 to press কৰিছো কিন্তু ইয়াত হোৱা নাই মানে আহা নাই বস্তুটো মোৰ ল্যাপটপত দেখাই দিছে মানে কিন্তু ইয়াত শো কৰা নাই
তুমি তাত from beginning বুলি যিটো আছে তাত ক্লিক কৰাচোন
দেখাইছে নে এতিয়া স্যাৰ নাই হোৱা চাগে
নাই অহা ওকে
ল্যাপটপত কিন্তু আহিছে বস্তুটো কিন্তু হেৰিয়াত দেখা নাই
আহিছে ইয়াত অহা নাই okay maybe some network issue I will see. Okay, you may start.
Okay. Now first one is card classification and regression tree. Shortly, card methodology refers to these two types of decision tree. This is called classification tree, and second one is regression tree. Now we discuss about classification tree. A classification tree is an algorithm where the target variables is fixed or categorical. The algorithm is then used to identify the class within which a target variable would most likely fall. Now, discuss about regression tree. A regression tree refers to an algorithm where the target variable is and the algorithm is used to predict its value. As an example of a regression type problem, you may want to predict the selling prices of a residential house, which is an continuous dependent variable. Now, the next one is wait. Yeah. The next slide is when to use classification and regression tree. Classification tree are used when the dataset needs to be split into classes which belongs to the response variable. In many cases, the classes yes or no. And the second one is regression tree are used when the response variable is continuous. For instances, if the responsible variable is something like the price of a property or the temperature of the day, a regression tree is used. Now the our second topic is ID3. ID3 stands for iterative decromat. Hello. Tree.
Yeah, you're audible. You can say.
Algorithm used to generate a decision tree. The ID3 algorithm was invented by Rose Weinland. Now, the advantage of ID3: understandable prediction rules and created from the training data. Build the faster tree. Next, build a short tree. Now, and the last one is one only need to test enough attributes until all data is classified. These have some disadvantages of ID3. The data may be overfitted or overclassified if a small sample is tested. Only one attribute at the time is tested for making a decision. The last one is classified continuous data may be computationally expensive as many trees must be generated to see where to break the continuum. Thank you.
Okay. Thank you, Gopal. Next, from MSCID, no one is there. No one is there. Okay, from MCA. From MCA, Meghna, you can start.
Thank you, Ankit. Good afternoon, everyone.
Yeah.
Myself is Meghna Panik from MCA 5th semester. Today I will be talking about ID3 and CART. ID3, wait a second. Is my screen visible?
Yeah, it is visible. Put it on the view mode. Can you slide mode on this one?
I did.
Okay. Oh, yeah, it is coming. Right.
Okay, thank you. ID3 algorithm stands for Iterative Dictomizer 3, and it is named such because this algorithm iteratively or repeatedly dictomizes, that is, divides features into two or more groups at each step. ID3 uses a top-down greedy approach to build a decision tree. In a simple top-down approach, we just start building the tree from top, whereas in a greedy approach, at each iteration or repetition, the best feature at present moment is selected to create a node. ID3 steps include the calculation of information gain for each feature. Considering that all rows don't belong to the same class, we need to split the data set into subsets using the features for which the information gain is maximum. Then we need to make a decision tree node using the feature with the maximum information gain. And if all rows belong to the same class, then we need to make the current node as the leaf node where the class as its label. We need to repeat the same steps for the remaining features until we run out of all features or the decision tree has all its leaf nodes. The advantages of using ID3 are building a fastest tree using ID3 tree. We can build the short and fastest tree. We only need to test enough attributes until all data is classified and the whole data set is searched to create a tree. The disadvantages include the data may be overfitted or overclassified if a small sample is tested. Only one attribute at a time is tested for making a decision. And classifying continuous data may be computationally expensive as many trees must be generated to see where to break the continuity. A CART stands for classification and regression tree. A CART tree is binary tree that is constructed by splitting a node into two child nodes, which is repeatedly and beginning with the root node that contains the whole learning sample. The advantages of using a card tree are that the decision trees can inherently perform multi-class classification. They also provide most model interpretability because they are simply series of if-else conditions. They can handle both numerical and categorical data. Nonlinear relationships among features do not affect the performance of the decision trees. The disadvantages include a small change in the dataset can make the tree structure unstable, which can cause variance. The decision tree learners create underfit trees if some classes are imbalanced. It is therefore recommended to balance the dataset prior to fitting with the decision tree. Thank you.
Okay, thank you, Meghna. And the next one will be Rahish from Integrated MSCRE. Rahish? Okay, yeah.
Can I start? CART algorithm is structured as a sequence of questions. The answer to determine what the next question, if any, should be. The result of this question is like a tree structure where the end are terminal nodes at which point there are no more questions. The main elements of cards are rules for splitting data at a node based on the value of one variable. Next is stopping rules for deciding when a branch is terminal and can be split or no more. And finally, a prediction for the target variable in each terminal node. And some there are some advantages of cart as follows. The cart is non-parametric and therefore does not rely on data belonging to a particular type of distribution. Cart is not significantly impacted by outliers in the input variables. Cart incorporates both testing with a test data set and cross-validation to assess the goodness of fit more accurately. Cart can use the same variables more than once in different parts of the tree. Another cart can be used in conjunction with other prediction method to select the input set of variables. And the next is ID3, iterative dichotomizer tree is an algorithm which is invented by Ross Quinlan, used to generate a decision tree from a data set. ID3 is the precursor to the C4.5 algorithm, which is typically used in the machine learning and natural processing language. Then, what should I say? They are following next is the properties of ID3. ID3 does not guarantee an optimal solution. It can converge upon local optima. It can use greedy strategy by selecting the locally best attribute to split the dataset on each iteration. ID3 can overfit the training data. To avoid overfitting, smaller decision trees should be preferred over larger ones. Then ID3 is harder to use on continuous data than on factored data. Factored data has a discrete number of possible values, thus reducing the possible branch points if the values of any given attributes are continuous. Then there are many more places to split the data on this attribute, and searching for the best value to split by can be time consuming. That's all. Thank you.
Okay, thank you, Rahish. Next, Bandhan, please proceed.
Okay, Mohori. Ankit. In order to understand classification and regression tree, better we need to first understand decision tree, and how they are used. Didiman, stop sharing. Hello. Yeah. The decision tree algorithm are nothing but if-else statement that can be used to predict a result based on data. The card methodology refers to two types of decision tree. One is classification tree and another is regression tree. In classification tree is a algorithm where the, where the third my just a second. Yeah. Regression tree refers to an algorithm where the target variable is and the algorithm used to predict its value. An example of regression tree problem, you may want to predict the selling price of a resident house, which is a continuous variable. In ID3 algorithm can be used to construct a decision tree for regression by replacing information gain with standard deviation reduction. A decision tree is root node and invoke partitioning the data into subset that contain instance with similar values. So that's all. Thank you.
Okay, thank you, Bandhan. Next, Didiman Hazarika, you can share your slide.
Thank you, Ankit. A very good afternoon to all of you. Is my screen visible to all?
Didiman, your voice is too low.
Okay, I have some network connectivity. Is it okay now? Hello, can you hear me?
No. Voice is little low.
Now can you hear me?
Yeah. Now it is okay.
Okay, so today
Yeah. Now it is
I'll
okay.
be presenting about the CART and ID3 algorithm. So basically, what is CART? So first I will begin with the ID3 algorithm, that is iterative dictomizer. So it was developed by Ross Quillen. It builds the decision tree on a given dataset in a top-down fashion. Okay, that starts from a set of objects and the specifications of properties, resources, and information. Each node tree tested based on maximizing information gain, minimizing entropy, and results are used to split the object set. This process is recursively done until the set subtree is homogeneous. That means objects belonging to the same category. And the ID3 algorithm uses a greedy search, selects a test using the information gain criteria, and never the possibility of alternate choices. So what are the steps involved? Firstly, the information gain of each feature that are involved in the dataset are calculated. Now, considering all the rows that belong to the same class, the dataset is splitted into different subsets. After that, a decision tree is made using the feature having the, that means the root node is made by the feature having the highest information gain. So let's see the remaining process by an example. So this is the steps that I have discussed already. So let us consider a simple dataset of COVID-19 infection. So you can see there, this is the ID number. There are like total 14 sets, and this fever, cough, breathing issues, infected. These are the features of the dataset. Now, as you can see, we will try to find out the information gain of fever, cough, and breathing issues. The information gain of breathing issues is more, so it is used for creating the root node. So you can see the breathing issues, and then it is yes and no. After that, we decide which one is the best for left branch of breathing issue, out of fever or cough. And same way, we will again calculate the information gain of fever and again what cough. And after that, we'll get the information gain of fever is more. So fever will information gain of fever will be on the left side. Now, after that, the subset of rows from original data set have the breathing issues value as yes and fever as no. The values are no, and hence no means no defines not infected. After we repeat the same process for the node cough, however, here both left and right leaves turn out to be the same. That means they're all not infected. So ultimately, the final decision tree comes out to be like this. The breathing issues is on the top node, and the other features are below it. So this is the decision tree. Now, what are the disadvantages associated with this algorithm? As you can see, data may be sometimes overfitted or overclassified if a small sample is tested, and only one attribute is taken at a time for making a decision, and it doesn't handle numeric attributes and missing value. And also here, pruning is not involved. Now, moving on to the next topic, that is CART. CART stands for classification and regression tree. It constructs binary trees, namely each internal node has exactly 2 outgoing edges. Now, first, classification trees. So these are the trees in which target variable is categorical, and the tree is used to identify the class within which a target variable would likely to fall into. And the regression trees are the trees where the target variable is continuous and tree is used to predict its value. The CART algorithm is structured as a sequence of questions, the answer to which determine what the next question will be. And based on that, the result of this question is like a tree structure where the answer terminal nodes, at which point there are no more questions. So lastly, the advantages are, first one is that it can split on only one variable, and the second point is that trees form may be unstable. So that's all. Thank you.
Okay, next, Kashavi, you can share your screen.
Yes, okay, wait. Wait, huh? Is my screen visible? Hello?
Yes. Yes, it is visible.
Okay. So, good morning, good afternoon, everyone. So now I will be discussing on the topic CART and ID3. So at first, what is CART? So a classification and regression tree is a predictive model which explains how an outcome variable's value can be predicted based on other values. So here CART stands for classification and regression tree. With decision tree, each fork is a split in a predictor variable, and each end node contains a prediction for the outcome variable. So how does CART works? The algorithm is based on classification and regression trees by Brenman, A. card tree is a binary decision tree that is constructed by splitting a node into two child nodes repeatedly, beginning with the root node that contains the whole training sample, y the dependent variable or target variables. So here in this figure we can say that it decides. So it is it is basically a binary tree. So in this we are deciding whether if it is in yes or no, true or false, right? So if the height is greater than 180 centimeter, yes, then he is male. If no, then check the weight. If the weight is greater than 80 kg, if yes, then male, and if no, it's female. It's just a prediction here. It's not true. So so now let's move to ID3. So ID3 is iterative uh, decode, dichotomizer tree. It is an algorithm invented by Ross Quillen used to generate a decision tree from a dataset. So ID3 is the precursor to the C4.5 algorithm and is typically used in machine learning and natural language processing domains. So how does it work? So ID3 uses a top-down greedy approach to build a decision tree. The top-down approach means that we start building the tree from top, and greedy approach means that at each iteration we select the best feature at the present moment to create a node. So in this picture, we are trying to classify a person whether it is fit or unfit. So the decision note here are questions like, is the person less than 30 years of age? Does the person eat junk, etc.? And the leaves are one of the two possible outcomes, that is fit and unfit, right? So now looking at the decision tree, we can say like it makes the following decisions. So if a person is less than 30 years of age and doesn't eat junk food, then he is fit. And if a person is less than 30 years of age and eats junk food, then he is unfit, and so on. So the initial node is called the root node here, which is the blue one. And the final nodes are the leaf nodes, which are the green ones. And the rest of the nodes are called intermediate or internal nodes. So the root and the intermediate nodes represents the decision, while the leaf node represents the outcomes. So that's it. Thank you.
Okay, next, Jyota, please share your screen.
Yeah, just wait a minute. I'll be sharing. Is it visible?
No, till now.
Uh, uh, Now it's visible.
Yeah, it is visible now.
Okay. So, good afternoon, everyone. So today's discussion topic is about CART and ID3 algorithm. So, CART algorithm. So it generally stands for classification and a regression tree. So we all know that in decision tree are commonly used in data mining that creates a model which predicts the value of target, that is the dependent variable, based on values of several input, that is independent variable. So CART generally constructs binary trees where each node has two outgoing edges. So whereas in ID3 or any other algorithm, it generates the decision tree with variable branches per node. So that's the difference. So classification tree is a tree where the target variable is categorical, and tree is used to identify the class within which a target variable would likely fall into. So regression tree is where the target variable are continuous and tree is used to predict its values. So regression trees are the trees where the leaves predict a real number and not a class. So the card algorithm is structured, which is a sequence of questions, and the answer determines what the next question may be. So it's generally a tree-like structure where the end are terminal nodes and where no questions can be formed. So let's see with an example. So here's a question asked: is it raining or not? So yeah, if it's raining, then is it hot? So if it's hot, then it's bad, and if it's not hot, then it's good. So similarly, if like we say that no, it's not raining, then there is a question like, is it windy? So it can be yes or no. So if it's windy, then it's a bad weather, and if it's not windy, then it will be a good weather. So this bad, good are generally the terminals, and that these terminals cannot be used to make questions since they are the leaf nodes. So advantages of card algorithm. So it can easily handle both numerical and categorical variables. So numerical variables, it's those variables where the measurement or number has a numerical meaning. Like for example, we can say heart rate, that is heart rate. So it can be represented as numerical. So categorical variable refers to the variable where a category is used or type is used. For example, we can say a gender, which can be categorized into male or female. So card algorithm easily identify the most significant variable and eliminate the less significant ones. And it can easily handle outliers, which means that when we are working with like machine learning algorithms, we generally deal with outliers, right? So our main job is to remove those outliers. So outliers is mainly the observation that lies an abnormal distance from other values in a random sample. So if we try to remove those outliers so that the models like provide more accurate results. So next is ID3 algorithm. It generally refers to iterative dichotomizer tree algorithm. So it generally follows top-down greedy approach, which means that we start building the tree from the top, and a greedy approach means at each iteration we select the best feature at the present moment to create a node. So ID3 algorithm selects the best feature at each step while building a decision tree. Mainly uses information gain to find the best feature that calculates the reduction in entropy and measures how well a given feature separates or classifies the target classes. So higher the information gain is reached, so it's selected. It's the best one to select. So let's take an example. If the target attribute is as play, so it can be three weather conditions. It may be sunny, overcast, or rain. So if it's sunny, it arises a question like is it humid or not? So if it's not humid, like if it's normal, then it is regarded as yes. And if it's high in humidity, then no, which means that yes, no refers to like yes, they can play, and no means yeah, no play can be done. Similarly, when there is wind, if there is a strong wind, then yeah, no one can play. And if it's weak wind, everyone can play. So that was a small example of it. So that's it. Thank you.
Okay, thank you, Jweta. Okay, no one left, I think, right? Okay, I'm sharing my screen now. It is visible, right?
Yes, it's visible.
Okay, so let's start. Wait, let. Yeah. Okay, so good afternoon, everyone. My name is Ankit, and today discussion topic is about CART and ID3. So I have given some. I will discuss all the overviews is important for us. So first card, that is the classification and regression tree. So what regression tree do actually? It use mean by average. It means that see regression tree we use when the dependent variable is continuous. So in the last DWDM class, I have discussed about this one, regression analysis, isn't it? So dependent, I have discussed about the dependent variable and independent variable. Okay, so that is what I'm saying, that regression tree are used when the dependent variable are in continuous in nature. Okay, and use mean by average means the value obtained by the terminal nodes in the training data is the mean or the average response. And in the classification tree are used when the dependent variable are categorical in nature. There is use mood by average means that the value or the classes obtained by the terminal node is that in the training data is the mood of the observation falling in the region. Okay, so that is the thing. Okay, next the advantages of disadvantage and advantages of the card. See, first the advantages, it is simple to what? Simple to understand, simple to interpret and visualize. And the second point is variable screening or feature selection. Yeah, so it can handle both the numerical as well as the categorical data. Because why? Because both the classification and regression is there, isn't it? So it is called like classification and regression tree, which is the generalized, make more generalized the decision tree, make the decision tree more generalized, isn't it? So little effort for data preparation, that is the third point. That means it can also handle the multiple output problems that the decision tree requires, and it can relatively, we need a little effort from the user for the data preparation. Okay, so disadvantages, first is overfitting. See, while programming decision tree, we can create over complex that do not visualize, or we can say that we can that do not properly generalize the data well. That is what overfitting takes place. And decision tree will be unstable because some small variation, for the small variation of the data set will maybe there. Okay. Okay, so I've included the classification part, how it, the mathematical observation, how it take place. See, the Gini equal to 1 minus summation of probability, and the I means the number of the classes, or we can say the instances. So in the last example, I think you all have remembered the table. There are total 14 observations there. I have not included the table here, but you all have remember, I think there are total 14 observations. So how the calculation takes place actually. See, look the table. There are Sunny, like yes, no, okay. We have the total instances is 5, like this. We have calculated the instance. Then we will calculate like this. See the formula. Gini 1 minus summation of probability. Then the instance. Then we have to square it. Okay. See, same thing I have done here. I have taken the summation, means the total 2 by 5 square minus 2 by 5. We will find the value. After that, we will find the value of the complete outlook. That will be the total observation divided by the total observation with the number of the instance. Okay, so please calculate this. You will get one value. Okay, we will find the lowest value of the feature which has the lower Gini index. Okay, the part which will be have the lower Gini index, we will consider that. This is where how takes place classifications takes place, calculation. Okay, next is ID3, that is iterative dichotomous 3. I have included this term, the dichotomous, in the logistic regression, I think. So here is also there that iterative dichotomous, or that classifying the considering the two classes, isn't it? This algorithm begins when the original set is the root node. See how it is work actually. First it select, after the selection is complete, it is stop. Okay, I have not discussed the algorithm, but yeah, iterative dichotomous work like this, that first it start from the root node, isn't it? We will start from the root node, the initial point. So the original set is the S. Okay, so on each iteration of this algorithm, it iterates through every unused attribute. That is the from the root node. We'll consider that, and calculate the entropy. After calculating the entropy, we will calculate the information gain of the set, that is the original set of that attribute. So I have discussed a little bit of entropy. So this is the entropy formula, we know, isn't it? So how it is work? See, for the sample of negative and positive elements. So so here it is given that S contain 14 examples. Okay, 4 value is positive and 5 value is negative. So you just put the value for the positive. You can get you will get the entropy. So what we actually trying to do actually, see, if we get more information, if the information gain is more for us, then what will be the entropy? It will be less, isn't it? Sorry, information, if we get more information, then there will be less uncertainty, isn't it? If there is less information gain, then the entropy will be more, isn't it? There will be uncertainty. How the ID3 process takes place. First, take all the unused attribute and calculate their entropies. Okay, then it choose the attribute that has the lowest entropy in the minimum, that is minimum, or the information, and the information gain is maximum. What I said is, like if the information gain is more, then the entropy is less, isn't it? And one more thing I want to include, that see, information gain and the Gini index are not applicable to decision tree regressor, or to calculate this one impurity, Gini impurity and all, because see, the target variable, the target variable in the decision tree regressor is a continuous value, isn't it? Is a continuous value. So every value present is unique in nature, isn't it? So we will not consider that is not applicable. That one, this Gini information gain and Gini index. So next, make a node contain that attribute. Okay, this is the process. So the advantage and disadvantage. So ID3 algorithm we can build it fastest tree, and build a shortest tree. We can just import an attribute, which is the important attribute we can consider from refining it. And the disadvantage is only one attribute at a time is tested for making a decision. So it will take much time for that. Okay, so thank you, everyone.
Thank you, Ankit. That's a very good presentation, and thank you all of you. Have tried your best. So, how many candidates participated? That currently 7. So, what is our overall rank? I think more than 30. So 7.
Sir, voice is low, sir. Actually,
Yes. Okay, let's see. Well, then we can conclude today's
okay, yes, sir.
I'll notify about the next topic. Okay. Thank you.
Okay, sir. Okay, sir. Thank you, sir.